Hi, sixth grade. Let me just get my PowerPoint ready. Oh, did I do float on top? See, you float on top. Okay. Okay. Oh, how was your spring break? I hope you had a great time, and I hope you had a great Easter. So today we're going to learn how to find the area of a triangle using a formula. You might be wondering, what does formula mean? I'll get to that a little bit later, okay? I'll clarify that a little bit later. So before we begin, I want us to watch a video that'll review different types of triangles. It'll be just for 2 minutes, okay?
Hi, welcome to Mathantics. In this geometry lesson, we're going to learn all about triangles. You may remember from the lesson about polygons that triangles are special polygons that always have 3 sides and 3 angles. And that's what the word triangle means. Tri means 3, and angles means angles. Okay, that's easy enough. 3 sides, 3 angles. But what else is there to know about triangles? Well, for starters, we're going to learn how to classify triangles. Ooh, such a classy triangle. But seriously, there's 2 different ways to classify or organize triangles. They can be classified by their sides, and they can be classified by their angles. Let's start by classifying triangles by their angles, since we've already learned a lot about angles in the previous videos. You may remember from our first video about angles that there's 3 types of angles. There's right angles, acute angles, and obtuse angles. Well, watch what happens if we use a third line in each of these angles to form closed shapes. Aha! Triangles. And can you guess what these 3 different kinds of triangles are called? Yep, the one made from the right angle is called a right triangle. The one made from the acute angle is called an acute triangle. And the one made from the obtuse angle is called an obtuse triangle. So that's simple enough. But notice that for each of our 3 triangles, the new angles that were formed when we closed the shapes are all acute angles. So triangles always have at least 2 acute angles. And it's the other angle that determines what type it is. That's important to know so you don't get tricked. For any given triangle, just because you see one acute angle, that doesn't mean it's an acute triangle. You have to look at all the angles to tell if it's an acute triangle. The situation's easier with right and obtuse triangles because you can only have one right or obtuse angle per triangle. So as soon as you spot one of those kinds of angles, you know what type of triangle you have. All right then?
Okay, so let's review the different types of triangles. Do you guys remember the 3 types that were in the video? If you said acute, right, and obtuse, good job. So I just drew some examples of an acute, right, and obtuse triangle. An acute has all 3 acute angles, which means all 3 angles are less than 90 degrees. In a right triangle, there is one right angle, which means that right angle is 90 degrees. And an obtuse triangle has one obtuse angle, which means that one angle is greater than 90 degrees. So before we watch another video, please recall, okay, that the area of a rectangle is length times width, okay? Please remember that. I think you know it because we've done that in a couple of word problems. So, all right. So now this is what we're learning. We're going to learn how to derive the formula for the area of a triangle, okay? You might be wondering, wait a minute, what does derive mean? I feel like I kind of know, but I don't know the exact definition. Well, some synonyms of derive are to deduce, to extract, or to infer. Um, and what does formula mean? Well, formula in math means it's a math rule or equation. And so basically, we're going to learn in the next video how to infer how to get the math equation for the area of a triangle with what we know so far. And what we know so far is the area of a rectangle, right? So let's just watch the video. It's gonna be about 5 minutes, okay? And let me just go to the correct spot. 456.
Formula for finding the area of any triangle. But to do that, we're going to start with a rectangle again. What? The dimensions of this rectangle are 3 meters by 4 meters. So, what's its area? Well, using our formula, we know that the area would be 3 meters times 4 meters, which is 12 meters squared. But now, what if we were to cut this rectangle exactly in half along a diagonal line from opposite corners? It forms 2 triangles. And because each of these triangles is exactly half of the rectangle, that means that the area of either triangle must be exactly half the area of the rectangle. We already calculated that the area of the entire rectangle is 12 meters squared. So the area of this triangle must be 6 meters squared, and the area of this triangle must be 6 meters squared, since 6 is half of 12. Aha! So the formula for the area of a triangle should just be half of a rectangle. So does that mean that instead of area equals length times width, it should be area equals 1/2 of length times width? Yep, that's basically it, but with one important difference. Instead of L for length and W for width, we're going to use 2 different names for our triangle's dimensions. We're going to call them base and height, and here's why. The names length and width worked okay for this right triangle, because the right triangle is exactly half of a rectangle. But those names don't really work for other kinds of triangles, like acute triangles or obtuse triangles, because how do you tell which side should be which? So for triangles, we do something different. First, we choose one of the 3 sides to be the base. It doesn't really matter which side you choose, and in a lot of math problems, the base will already be chosen for you. Once we decide which side the base is, we imagine setting the triangle down on the ground so that its base is flat on the ground, like this. Next, we find the highest point of the triangle, which is the vertex that's not touching the ground. From that point, we draw a line straight down to the ground. The line we draw must be perpendicular with the ground. The length of that line from the tip of the triangle to the ground is called the height of the triangle. Oh, some people call the height of a triangle the altitude, which makes a lot of sense if you pretend that your triangle is a tiny little mountain. Sometimes the height line is inside the triangle, like with an acute triangle. And sometimes it's outside the triangle, like with an obtuse triangle. And sometimes it lines up exactly with one of the triangle sides, like with right triangles. But no matter where it is, the formula for finding the area of any triangle is the same. Area equals 1/2 base times height. So if we know these 2 measurements, base and height, we can just plug them into our formula to calculate the area. At first, you might not see how the same formula could work for all 3 types of triangles, but watch this. Here's an acute triangle, and this box is 1/2 its base times its height. If we cut our triangle up, you can see that it fits perfectly inside that area. But wait, there's more. Here's an obtuse triangle with a box that's 1/2 its base times its height. Again, if we cut up the triangle, it fits perfectly inside the box. Now you can see how the formula, area equals 1/2 base times height, works for any kind of triangle. Okay. We already figured out that the area of this right triangle was 6 square meters. So let's practice using our new formula to calculate the area of these last 2 triangles. Our diagram shows that the base of this acute triangle is 5 meters and its height is 8 meters. So we plug those values into our formula for area and we get area equals 1/2 of 5 times 8. 5 times 8 is 40, and 1/2 of 40 is 20. So the area of this triangle is 20 meters squared. Don't forget that the units of measurement for area will always be square units. Okay, that was pretty simple. Let's try our last example. The diagram of this obtuse triangle tells us that the base is 4 inches and the height is 7 inches. So let's plug those values into our formula. We end up with the equation area equals 1/2 of 4 times 7. 4 times 7 would be 28, and then we can calculate what 1/2 of 28 would be by dividing by 2. 28 divided by 2 is 14. So the area of this obtuse triangle must be 14 square inches. Okay, now you know all the basics of area. You know that area is a two-dimensional quantity that we measure in square units. You've learned the formula for calculating the area of any square or rectangle. Area equals length times width. And you've learned the formula for calculating the area of any triangle. Area equals 1/2 of base times height. But don't forget to practice what you've learned by working some problems on your own. That's how you really get good at math. As always, thanks for watching Mathantics, and I'll see you next time.
Okay, so in summary, the area of a triangle is 1/2 times base times height, or you can write it as 1/2 BH, where B and H might be unknown. And remember when we learned about variables and equations, when we have like a number, like a fraction next to a variable, next to another variable, it all just means to multiply, okay? So that's another way that you might see it in your book, okay? All right, and how do we find the base? Well, the base can be any side of a triangle. It has to be the side of a triangle, and thankfully in our books, the base will be chosen for us already. And what is the height? Well, the height is dependent on the base because you have to draw the height according to what your chosen base is, okay? And the height is perpendicular to the corresponding base. And it also touches the opposite vertex of the base. Or I guess in mathantics term, they use it is the highest point, right? In the triangle, the highest vertex in the triangle once your base is put on the ground. So do you guys remember how we reviewed these different types of triangles, the acute, right, and obtuse? Well, let's just allocate a base, and to make it easy, I'm gonna put the base flat on the ground, the side of the triangle that's flat on the ground. And so do you see how each of the triangles are, the base is in red? Yeah. Okay. Now we have to try to draw the height, okay? Now remember the height is perpendicular to the corresponding base. So let's look at the acute triangle, okay? So it has to be perpendicular to the base. That means when it touches, the height touches the base, it has to be at a 90-degree angle, okay? Between the base to the height, okay? And so here, there is the height, okay? And you can see it's a height because it's perpendicular to the base, and it also goes, touches the highest vertex of the triangle. All right, so now let's look here, okay, at the right triangle, okay? In a right triangle, the base is the other side of the triangle because it already makes a 90-degree angle, so it is already perpendicular. And the obtuse one is a little bit tricky though, okay? Because if we look at the base of the obtuse and then the highest vertex, once the base is on the ground, it's kind of further beyond the base, right? But it's okay. We just take we just need to draw a straight line from the highest point of the vertex of the obtuse triangle and draw it straight down. So then to the ground, it makes a 90-degree angle and is perpendicular, kind of like that. Okay, and so now we have a base and height. Okay, so you might have these triangles that are shown up in the problems that might be easy to find the height and the base, but sometimes you might have to kind of move your book around and put the base at the bottom on the ground, like flat on the ground, for you to kind of see with your eyes, like, oh, where is the height? So that's what you might have to do. All right, so now I want you to pause the video and try to do guided practice numbers 1 and 2, okay? And when you're ready, just play the video. All right, welcome back. Hi. So let's look at number 1, okay? So in here, they don't give you centimeters, they don't give you inches or meters. They just say the unit of measurement is a unit, okay? For me, the base, I'm gonna say that's the base. You could say the other side is the base as well if you wanted to, but I'm gonna allocate the one that's kind of on the ground as a base, okay? And I count that as 5 units. Now the height, I see the height is right there because it's perpendicular to the base and it touches the highest vertex, okay? And that's when I count the graph. There's 1, 2, 3, 4, 5, 6, 7. That's 8 units, okay? And so now I'm going to input it into the formula for area is equal to 1/2 base times height, okay? And so here, all right, what I did was, this is actually the exact same problem that was given in the video, wasn't it? Okay. Now, what I like to do is, I like to, when I look at this, because all the terms, we are multiplying this with this with this, order doesn't matter. Okay, you can do 1/2 times 8, then you can do it by times 5, right? Or you can do 1/2 times 5, then times 8, okay? But I notice this, 5 times 8 is 40. And then half of 40 I know is 20, okay? And then, so the area of that triangle is 20 square units, okay? Now let's look at number 2. That one, what kind of triangle is that? Is it an acute? Is it a right? Is it an obtuse? Well, it's an obtuse triangle, okay? Now with this one, you might have to kind of flip the book a little bit if you want the side of the triangle that's allocated as a base to go on the ground, okay? But I just kept it as is. So I'm going to allocate that as a base because that clearly shows me how long that side of the triangle is, okay? And so I count that as 3 units long. And then, so then the height is there, okay? That's the height. And I see when I count the boxes, that is 4 units. And again, I'm gonna input that into my formula for the area of a triangle, and I get this, okay? And again, I notice here, it is, you know, I don't want to do 1/2 times 3 because that's 1.5, okay? But I see here 3 times 4 makes 12, and half of 12 is 6, okay? So this is 6 square units, like this. All right, next. Woo, good job. All right, would you please complete guided practice numbers 3 and 4 and pause the video, work on it, and then when you're ready, play the video again. See you soon. Hey, welcome back. All right, so in here, let's see, what can we determine the base as? Well, let's go back to the definition of a base of a triangle. The base of a triangle is one side of a triangle. Now, in the picture there, which side did they tell you? the length of. Oh, they told you the length of side BC. Do you see that in the picture? Okay, so the base is 2.1 centimeters, and then if that's the base, then the height is 1.8 centimeters. So then now I'm going to plug that in into the formula for the triangle, area of the triangle, okay? And you should get something like this, 1/2 times 2.1 times 1.8, okay? So I'm gonna do 2.1 times 1.8 first, okay, just to see what I get, okay? And notice when I'm multiplying a decimal by a decimal, okay, you can ignore the decimals for now, but you have to remember that, oh, how many numbers come after the decimal point. So in here, there's one number that comes after the decimal point. In here, there's another number that comes after the decimal point, okay? After the decimal. And we're going to add it together, and that's 2. So once we figure out the answer here, when we multiply 2.1 times 1.8, in our final answer, we're going to go back 2 places, okay, to get our final answer. Let's see what we got to do. So 1 times 8 is 8. 2 times 8 is 16. 1 times 1 is 1. 1 times 2 is 2. Then we add it. So then that's 378. But then I remember from here, I have to go back 2 decimal places. Okay, so it's 3.78. Okay, so that's 1/2 times 3.78. So it's half of 3.78. And then you can just divide this by 2, okay? And if you do that, you should get 1.89, okay? All right, let's try number 4. Number 4, all right, so number 4, let's see, remember the definition of a base is just one side of a triangle, okay? So is XR a side of a triangle? No, it's not. QR is the side of a triangle, so that can be the base, okay? XR cannot be the base because you see how there's the part XQ that is extended from QR? That XQ is not part of the triangle, okay? So just be careful with that, okay, later on. Now QR is a base, and that's 3.4, and then the height then would be PX, which would be 2.7. And then you're going to input that in again, like so, 1/2 times 3.4 times 2.7, and then you guys should have gotten 4.59 square feet. Good job. All right, well, we'll practice this more tomorrow, and please get some questions ready on Thursday when we meet for our GoToMeeting session, okay? All right, have a good day. Bye.